So today, or this afternoon, I will be talking about actually 4 things. First, I will give you a quick introduction who NVIDIA is, a quick overview, and then there will be 3 other topics. I will be talking about Grid for VDI, what our Grid cards bring to VDI. The second thing will be to talk about grid-enabled solutions. Clearly, it's not us, only us, but essentially we live in a big ecosystem. In order to enjoy the Switch experience, you need to have multiple pieces in place, and we'll be talking about all these different kind of items. And then the last part, which I'm actually most excited about, essentially, I will show you, we'll talk about different user profiles, and then experience. I will share with you quite a few side-by-side videos I have, with and without our GPUs, and basically, show you essentially where we can bring tremendous benefit to VDI. So this should be quite exciting.
With 5 more minutes, there are too many people coming in. So.
Oh, okay.
So if you want to just introduce yourself for a bit more.
Let's give. I think it's okay. So people should. There's a line. Okay. So then.
Sorry, we're just gonna.
Let's wait quickly. So. I think the last talk was a little bit longer, and everyone wanted to have a break. Okay, I think we're just going to continue. If people come a little later, they will still get a big chunk of the presentation. So maybe I just repeat quickly what I just mentioned before. I will be talking about 4 different things. First, we'll give you a quick introduction, who NVIDIA is, in which spaces we play. You probably know already NVIDIA, but a little broader overview what NVIDIA is. Then I will be talking about what GPUs do for VDI, and more particular what NVIDIA Grid can do for VDI. And then I will be talking about grid-enabled solutions. Clearly, we live in an ecosystem where we have the hardware, our graphics card, but essentially there are many different pieces to it, and I will kind of show you essentially what different kind of solutions are out there, and what are the pros and cons of these different solutions, how they actually work. And the last part of what I'm actually most excited about are, I will be talking about user profiles. I will show you these different types of users you have, and what kind of user experience you can expect if you use NVIDIA Grid. And I will have quite a few side-by-side videos showing you essentially the different solutions I kind of talked before, and I will show you how it actually compares in videos, and you can judge for yourself whether you think what NVIDIA does for VDI. And so by the end of the talk, I hope I can have shown you 2 things. So I've shown you the clear benefits of a GPU to accelerate VDI. And secondly, that today you can deliver a true PC experience for everyone anywhere. So let's get started. NVIDIA, probably most of the people know NVIDIA from the GeForce in the space of gaming. But clearly, NVIDIA today is a highly diversified company. NVIDIA offers products from smartphones or from superphones all the way to supercars, as you can see here on this slide. So we are in quite a few smartphones, tablets, and we also kind of power the infotainment system of the Tesla, for example. And while we're in a data center, we're in workstations, we're in laptops, and so basically there's a very large range of products NVIDIA is in there today. Other than what people maybe know in the past, where it was pretty much only the gaming platform. So more specifically about the different kind of products, I mentioned most people know GeForce, that's the gaming component. Quadro is our professional solutions kind of products for manufacturing and different kind of professional applications. And Tesla, which is our compute brand, essentially. For example, the fastest supercomputer in the world today is actually running today on NVIDIA Tesla cards. Clearly we live in, this morning was already mentioned, we live in kind of the post-PC era, and there are two pieces to it. There's on one hand side you have all these different mobile devices where we have our Tegra brand, and clearly you need another opponent to it, which is the data center. These mobile devices talk always to the other side, and that's where NVIDIA Grid lives. Grid essentially has three different products. There's a gaming component to it. There's Grid VCA, which is our solution, integrated solution, and Grid VGX, and that's what I will be talking about here today. So the big question is, why do you need GPUs for VDI? In order to understand this better, it makes sense to take a step back and take a look at maybe 2 decades or 3 decades back in time. So when we all got our first PC, we were probably all very thrilled. It was running on MS-DOS, but it was a great experience. Basically, we were liberated. We could do great things with this PC. I still remember when I was doing my typewriter class, and I was able to impress my teacher that I could print out this perfect score, and she didn't realize that I would just had typed it up, and of course you can type it up and make corrections, and everything is great. But this was a very limited experience. It was not graphical, and then maybe in the mid-90s, Windows or Microsoft introduced Windows 95, and maybe this was the revolutionary, essentially introducing a graphical user interface. Since then, a lot of things have changed, right? So initially, we were looking at graphs, 2D data, then we went to 3D data, 3D interactive data, and now you design cars, airplanes, skyscrapers, and whatnot, using workstations. And so we're living in an extremely visual computing world. Actually, Windows in itself, it's actually the graphical user application, right? It's extremely graphical rich, and but if you keep in mind, how do you get this visual experience? Is you have a PC with a graphics card in it. Without a graphics card, you cannot create this kind of rich experience. And that's exactly the big problem for VDI. VDI lives in data centers. These are servers which don't have graphics card. CPUs are great for many, many things, but they're not specialized on rendering graphics, and that's where a little bit of problem is. So basically, if you, in the past, VDI has been pretty much limited to task workers, and the reason was that you simply couldn't kind of create this kind of rich graphical experience. So it was limited to task workers, which maybe was your call center application, something which was not as graphical rich. So without a GPU, the VDI user experience is in fact quite limited. So what changes if you now add a graphics card to the data center? All of a sudden, you are able to serve essentially everyone. And I'm claiming here that you can deliver a true PC experience to everyone. Whether it is to the designer, we call that the most demanding user. These are the people who create your car. This is maybe the radiologist who will read your MRI result, or the person who designs the next large skyscraper, right? Or the producer who makes the next Hollywood movie. The next level, essentially, we have power users. These are the people who actually consume the data designers create. And so these are kind of maybe the worker on the factory floor of an automotive company, or the doctor who actually tells you about that your MRI result is actually fine. He doesn't need as much graphical graphics power than the designer, but essentially still needs a graphics company in order to kind of get the same visual experience. And then the next step down would be essentially the knowledge worker. These are kind of people like myself. We use maybe Microsoft Office. We use HTML5. We use maybe Google Earth. And so we use Windows 7, Aero. So we have today a certain expectation in terms of our user experience when interacting with a notebook or a laptop workstation or with VDI. And if you have a graphics card in your server, you can deliver, in fact, exactly that experience. So let's take a look how we do this, how we can deliver exactly this experience. Clearly, there are two components to it. There is software and there's hardware. Most people think, in the past that NVIDIA is famous for their hardware, but essentially our software is equally important. Just to put this in perspective, today NVIDIA, I think more than half of employees are actually software engineers, and so a lot of goodness actually lies in the NVIDIA software itself. So whenever you use an NVIDIA solution and you do not use the software, meaning the driver and the hardware together, so if you don't see the driver, you do not get the full experience, which you do not utilize fully your hardware. So clearly there are two pieces to it. So let's dive a little bit deeper in it and see how we can actually deliver this kind of true PC experience. So if you remember the days of the workstation, essentially how does a workstation deliver a good experience? I mentioned there's a driver and then there's the GPU itself, the hardware. These are the two pieces which are critical in order to kind of deliver this kind of visual experience. Once you put this now into the server, you have a little more complicated stack, and because you have it now in the data center, and essentially you need to find a way that the driver can actually talk to the GPU. For that reason, you need to have a grid-enabled or NVIDIA grid-enabled hypervisor, which kind of lets essentially the driver talk to your hardware. Then also in VDI, you want to remote this experience to some clients. And we add special kind of software to the virtual desktop agent and to actually take the latency out. So essentially we add, you can see here on the bottom line, you have the hardware, and then you have 3 layers of software essentially to deliver you this kind of true PC experience. So, as I mentioned, there are 2 pieces, the software and the hardware. I will take another step and go one level deeper and explain what kind of solutions there are. The easiest one probably is the hardware. Let's do that first. So NVIDIA Grid, or there are 2 different grid boards. There's NVIDIA Grid K1 and NVIDIA Grid K2. And these are designed for 2 different kind of user groups. K2 is purely about performance. This is for your designer, for your remote workstation. So here you have 2 high-end Kepler GPUs, which have 1536 CUDA cores per GPU, extremely fast memory, 8 GB of GDDR5 memory, and this is the best performance you can get, and actually have 2 of these very, very great performance packaged into one card. On the other side, you have NVIDIA Grid K1, which essentially is more targeted for user scalability. Here you have 4 entry-level kind of Kepler GPUs. In comparison, they have 192 cores per GPU, so there's a factor of 8 roughly between K1 and K2. But the key difference here is it has 16 GB of DDR3 memory. And so that difference in memory is so important because you need to have enough frame buffer for all your different users. So if you want to put a lot of users onto your graphics card, you have to have a lot of memory. And so for example, if you take, let's say, 256 megabyte of memory, basically you can do like 4 times 16, 64 users, for a good graphical experience. I think some people probably want to have even more, but I mean, just to give you some perspective. And so down here, I kind of have listed a couple of users. If you do it in a dedicated fashion, and I will talk about that particular solution in a second, you can have 4 users in a K1, scaled up to maybe 100. I mean, I think 2 years ago at GTC, during the keynote, essentially showed 100 VDI sessions run off a K1. On the other side, in the high performance sector, we have in a dedicated fashion 2 users, and then scale up to maybe 64. But again, this is dependent very much on the application you're running. And the key difference in between the factor of 2 between the K1 and K2 is predominantly due to the amount of memory you have available, 16 gigabyte versus 8. Then I want to point out 3 other kind of, on the software side. Both of these cards support OpenGL 4.3. This is the latest version of OpenGL. It supports Microsoft DirectX 11 in both cases. And both of these cards already support the virtual GPU, which will be released or announced or will be released later this year. And so if you buy these cards today, you will be, just with a software upgrade, you will be able to utilize this kind of complete virtual GPU or virtualization of the GPU itself. Clearly, both of these cards, I should mention, are actually,
So we've got a grid card here. This is K1, just going to pass it around for you to look at. We've also got a very sensitive detector at the back of the room, so if somebody does leave with this, we will know.
Yes, and I'm watching the door. So, and clearly these both boards, K1, K2, are passive boards, and so it's actually quite critical. You cannot just take it and stick it into your server, because you definitely run into problems because you need to cool it sufficiently. So in order to provide a solution, we need to have we have other partners. I mean, here I mentioned I listed a couple of OEMs which we work together. And so today you can buy Grid K1, K2 from IBM, from Dell, ASUS, Cisco, and Supermicro. And soon HP will follow with multiple different servers as well. So there's a large range of servers where you can purchase today already, and in the near future where you can utilize K1 and K2. So it's very, very critical if you, I mean, a lot of testing goes into kind of putting these cards into servers, because it's actually not so easy, because these are very power hungry. For example, K2 utilizes 225 watts, and so if you just try to do this on your own, you most likely will kind of probably kill the card, and kind of, it's also not the cheapest card in the world, and so you definitely want to kind of go with one of these kind of certified OEM platforms. So I talked now about the grid hardware itself. Essentially now you know the different cards, you know which servers you can buy them right now, and I'm constantly working on trying to qualify more and more servers. There are different vendors are on the list already, which we will be qualifying very soon. But let's take a look closer at the software level, essentially, and kind of understand what different software solutions are out there and how they work, and what kind of benefits, or what are the limitations, and and the pros and cons are. In order to understand this a little better, let's take a look what we want to try to replace, which is the PC. So PC has hardware, has a CPU, memory, storage, network, and a GPU, as I mentioned. So here then you run an OS on it, and on an OS you have these different applications. Currently the predominant ones are, or actually I should mention that you have the different hardware drivers, and as I mentioned before, you have to have the NVIDIA Grid driver in order to get the full benefit of the GPU itself. Only the package of the driver in NVIDIA hardware gives you the full benefit. Currently, essentially, solutions out there is predominant in terms of the OS is Windows 7, Windows 8, maybe Linux. So before I can now jump into all the different solutions, let's remind ourselves what are the benefits, or why you want to do virtualized desktops and applications. I mean, most of these people here, you're probably very familiar with it, but let's revisit it quickly. So the purpose here is to replace a physical desktop or laptop with a virtual desktop on the server. And I think we need to understand that clearly, in terms of benefits, there are different stakeholders. You have the IT department, which has certain kind of a certain agenda, and you have users who actually need to use it. So you need to understand the benefits in terms of these different stakeholders. The first three are here predominantly the benefits of the IT department. So you have security, So IP stays clearly in the data center, especially if you have models, if you're an automotive company, or you have IP which you definitely want to protect. It's definitely significantly safer to have it in the data center versus on some device. Yes, you can do encryption and so on, but I think, if you know it's in your data center, there's another level of comfort, essentially, for you. The next thing is since manageability. I think Brian this morning said, okay, this is not really quite the reason why you should do this, but I still believe, essentially, with all these different reasons, you have always a sliver of each of them where you get some additional benefit. It's not one of them which gives you everything. So I think in terms of manageability, it is essentially the whole problem with the device proliferation. Yes, it is predominantly an Apple iPad or something, but I think you have so many different devices, and IT department is kind of overwhelmed with, essentially, and that EVDI definitely helps you to kind of make this more manageable. Then the other thing essentially is OS image management and definitely disaster recovery. The last one is resource utilization, essentially kind of moving with the sun, essentially, where if you have departments who work in different parts of on the globe, you can utilize your physical resources, in a much better, and keep by sharing these resources and having a better ROI. And so that these are the benefits essentially for the IT department. But we believe that essentially the main driver for VDI will be actually will be driven by the users themselves. Essentially, we should actually look essentially what are the benefits for the end user, because they will determine whether they want to use it or not. And I think maybe the two main ones, is one is data centralization. It sounds a little bit, this is a benefit for the IT department, but I think it's a clear benefit for the user, because they can access now very large data files, they can get their work done, they can maybe spend more time with their families because they can do this more efficiently, and so they have a better experience when they need to work on very large data sets. So in that case, you have your compute and your storage resources significantly closer to each other. And then, of course, user flexibility or mobility. So you're no longer tied, to being, at work where you have your workstation on your desk. You can actually also work from home, or different other places. And other studies actually have shown. I think at GDC there was a talk by, I think, Applied Materials, who deployed a VDI solution, and they reported that they were able to, pay for this VDI investment by the productivity increase by the people who were using it. So I think productivity is a great thing here. So I think the main driver will be actually user flexibility, that the end user will get the same experience, but now they're kind of liberated in terms of they don't have to be at work anymore. You can do it from many different places, and you have an increase in productivity. So the key word here is any device, anywhere, at any time. So clearly, if you want to do VDI, there are two kind of ways of doing it. One is the Virtualized Desktop, and the other one is Virtualized Applications. So let's go first into the Virtualized Desktop and kind of look essentially what are the different ways you can do this. Okay, so in order to understand this better, again, the best way is to kind of revisit how a typical server looks like right now and how resources are virtualized at the moment. So again, you have your resources, you have a CPU, memory, storage, and you have your network. Then you put in a hypervisor on top of it in order to virtualize these resources. And you run a virtual machine where you have virtual memory, virtual CPU, virtual storage, and a virtual network. And then on top of in that virtual machine, you run your particular OS with these drivers and applications. And then, of course, you can do many of them, and that's the great benefit of virtualizing a data center. Well, in order to remote this, now essentially you need a VDA, a virtual desktop agent, to take the pixels and deliver them through the cloud to your different clients. And so what are the different solutions which are offered here right now? So on one side, on the hypervisor level, maybe the predominant one is VMware ESX or vSphere, and then you have Microsoft Hyper-V, Red Hat, KVM or Citrix XenServer, and you know that multiple other open source options there as well. In terms of OS, again, very similar to the PC, is Windows 7 or Windows 8. And then you have different options for your virtual desktop agent. You have Citrix Desktop, that's maybe the predominant one here, VMware View, Microsoft RDP, HP RGS, NICE, and VNC, and you know, maybe more. And then finally, you have multiple different protocols, how you can kind of remote essentially this experience from your data center to your client. There's ICA from Citrix, there's PC over IP, RDP, you know, among some other. And finally, you have the at the client side, you have the different receivers. You have the Citrix receiver, you have the VMware View, View client, you have Microsoft RDP, RGS receiver, just to mention a few. So this essentially was how a server looked like before you put a GPU into it. Now you actually, if you want to add a GPU, you have multiple options. There essentially, I will be talking about here 3 different options. The first one is GPU pass-through. That's a one-on-one dedicated GPU per user. The second one is shared GPU. That's a software virtualization technology. So on a software level, you kind of virtualize the GPU, and the multiple, I will talk in more detail how that is done. And finally, the true virtualization of a GPU, which is virtual GPU, that's true hardware virtualization through our NVIDIA Grid software. So let's take a look at the first one. So for GPU pass-through, you essentially start with the server you had before. You have a CPU, memory, storage, and network, and now you add a GPU. Then you essentially, literally, you carve a little hole into your hypervisor so that your virtual machine that this GPU gets passed through a virtual machine, and the GPU appears in the virtual machine itself. Since now the GPU is actually literally physical present in the virtual machine, you can also use the NVIDIA driver. So remember in the very beginning when I was telling you about that you want to always use the driver and the hardware together? Yes, now you see in your guest OS, you see the guest OS sees the NVIDIA GPU, therefore can use the driver, and now we get all the benefits of the NVIDIA package or the NVIDIA hardware. We have also then some special software in the virtual desktop agent to actually take out the latency and deliver a great experience to the client. And so what are the different products which support this kind of technology? There's clearly Grid K1, K2. They're all our Quadros 2000 to 6000 boards, and then also our Kepler technologies K2000 to K5000. At the hypervisor level, pass-through is supported currently by Citrix XenServer and VMware ESX. And for the driver, well actually here's first the accelerated remoting, essentially the only one which supports, or there are 2 options which supported right now. One is Citrix Zen Desktop 5.6 Feature Pack 1 and VMware View 5.2, which will be hopefully released soon. I mean, the first one, Zen Desktop, is already released, the second one will be released soon. Okay, so now the dedicated fashion or GPU pass-through was just a one-to-one mapping. So essentially, this is for your most demanding users, but clearly, ultimately, you want to kind of share the GPUs and kind of virtualize it. So the first step to doing this is GPU sharing. This is also known as software virtualization or API intercept. So let's take a look how that works. Again, it starts off in a similar way. You have your server, you place a GPU in it. Now, instead of having a hole in the hypervisor, the actually NVIDIA driver lives in the hypervisor itself. Because now the GPU is not visible to the virtual machine, you have a virtual graphics virtual graphics device appearing in the virtual machine, which is not actually the NVIDIA device. It's in this case, if you use, for example, VMware, it's the VMware, it's a virtual graphics card there. Because of this, you can only use a generic virtual graphics driver, and not the NVIDIA driver. The NVIDIA driver lives in the hypervisor. So in order to render graphics, this virtual graphics driver intercepts the API calls, sends them to the driver communicates to the GPU, sends back the vendor desktop, and gives it back to the guest OS, which then remotes it over to the client. And of course, you can do it many, many, many times. But the big difference is essentially it really just intercepts the API calls, sends it to the graphics, and sends it back. And this model has certain limitations. And later on, in terms of, I think, if you use the one technology which supports this is for the VMware VSGA, which currently supports OpenGL 2.1 and DX, I think, I'm not 9, actually not sure, I need to look it up. But I think it's not the OpenGL 4.3, it's only OpenGL 2.1. And of course, you can do it many, many times. So let's take a look which kind of solutions are supported here. In the hypervisor level, there are two different solutions. There's RemoteFX. I think we heard this morning about this. There are two different kind of flavors of it. You can use Microsoft Server 2008 R2, which supports DX9, Microsoft Server 2012, which supports DX9, 10, and 11, and then of course VMware VSGA, DX9, and OpenGL 2.1. And I think these differences in terms of the supported version of these graphics APIs is actually extremely important when you later on use certain applications, because especially in the CAD world, these applications will actually try to ask what kind of graphics card do I have, and depending on the graphics card it sees, it will actually go to a CPU rendering mode. So even though if it finds out in this particular mode, if you install, let's say, AutoCAD or something, and it only sees the virtual graphics driver and it doesn't see an NVIDIA driver or the NVIDIA device, then it will automatically assume that it doesn't have a graphics driver and goes to a fallback mode in order to give you just a CPU kind of rendering. And that's the problem there. And in terms of the graphics card, you have here supported Grid K1 and K2, Quadro 4000, 5000, 6000, and Tesla M20 2070Q. So let's talk about the things which will come out very soon, which is the true hardware GPU virtualization. So remember, the whole data or the whole hypervisor game or the whole data centers came about because you were able to virtualize these resources. But so far the solutions I've shown you are not true virtualization of the resources. Yes, you have shared GPU, which is an attempt but has certain limitations, but dedicated one-to-one clearly is not virtualization of the GPU, and that was the whole drive of moving things into the data center. But here with GPU virtualization from us, you will be able to do this. There are a couple of kind of synonymous terms. There's, whenever you hear NVIDIA Grid VGX technology, or you hear VGX and GPU hypervisor, vGPU, virtual GPU, or hardware virtualization, these essentially mean always the same thing, essentially true virtualization of the GPU through technology given to you by NVIDIA. And this is, coming very soon. So let's take a look how this actually works. Again, I start off with a picture initially. So you have here a server, you placed your GPU into it. Now essentially in the hypervisor, you have the special grid software sitting in there. And that software will enable such that in a virtual machine, now the NVIDIA device pops up as a vGPU. Because it's an NVIDIA device there, essentially now you can use the NVIDIA driver in the guest OS and can utilize the full benefits of the whole package. And then remote it over to the client, also with our technology. But how does it actually work? So it's not an API intercept model, and the driver is able to set through the grid software a state in the GPU, and then this state is modified through graphics commands. And so it's not just API intercept and you get a complete desktop back, but you have access to a certain kind of frame buffer, and you can read it out and so on. And that's actually the big difference between these two, between shared and GPU virtualization using our grid software. Essentially, in this case, the driver can talk through that software to the hardware, and you get the full benefit of the NVIDIA hardware. Yet now you can do it multiple times. You can sliver and slice your GPU in different pieces. And if you have a K1 or K2, you can pack a lot of users onto such a device. Yes, this is coming very, very soon. So if you go to some kind of big event in the near future, you might find out when this tech review will be available. So which hardware supports this particular mode? On the card, in terms of cards, it's so far grid in K1 and K2. The hypervisor which supports this right now, or will be supporting will be in the future, is Citrix Zen Server. And we of course hope that other vendors will actually adopt the same technology as well. But we would be happy to have everyone as a hypervisor vendor here to be listed here. And you get this grid software from us, from NVIDIA, as well as the driver. It's a standard driver. There's nothing different in the OS. And so that's actually one of the reasons why you get the same experience like a workstation.
There'll be no cost for the software.
In terms of cost?
For when it arrives. Is it something that's strictly free if you've already got a grid card or something like that?
Well, I think we kind of, I don't think we are in kind of, it will be part of the virtualization package, I believe. I'm not sure whether, this is very early on. We haven't even released it, but I think most likely it will be dealt with through the virtualization partner. But I think this is still something we need to find out. But it is definitely something more than just a driver. It's a special kind of software which you need to have for your hypervisor. And I think similar to them, I think the different virtualization partners, they have different packages. And I think maybe you can think about it exactly in the same way that you kind of enable a certain feature, and there's certain costs associated with it as well. Okay, so I talked now about virtual desktops. Let's briefly talk about virtualized applications, and then move on to the actually more exciting part to show you all these different kind of side-by-side videos and the user experience. So I will go over this rather quickly. So if you have virtual applications, as we saw this morning, essentially you have, in your server you install a grid card, you have your driver, and then different XenApp sessions can access the driver and then also GPU, and can deliver essentially great graphics acceleration to the different kind of clients. If you then look a little bit more closely, essentially how this is done, you have your server with a server OS, Windows Server OS. In that you have your different terminal sessions. In the terminal sessions you have XenApp running, where your applications get served. And if you now think about, you put the GPU in it, you have now your NVIDIA driver in the Windows Server OS. If you go through a terminal session itself, you only can serve up to DX9. But if you use, for example, XenApp, then you are able to have access to OpenGL 4.3 or DX11 because it can directly access your NVIDIA driver. So in terms of the different kind of the solutions which are out there right now. So you have Citrix XenApp 6.5, which supports DX9, whereas if you have Citrix XenApp 6.5 with the OGL add-on, you can now support DX11 and OGL 4.3. So this is in a bare metal system, but if you recall, for example, K1 has 4 GPUs and K2 has 2 GPUs. XenApp currently in this kind of setup can only access 1 GPU. So what do you do with the other GPU? You can either be a rich person and simply say, I don't care, or you actually put this into a virtualized, use virtualized machines. So you have your server, you put a hypervisor on it, and now you can have 2 different virtual machines. For example, if you have now a K2, you put that into the server, you use it in pass-through mode, they can talk to 2 different virtual machines, and then you actually build the same stack on top of it. One GPU appears in one virtual machine, the other GPU appears in the other one, and on top you have the same stack you had before, and now you can use a K2, for example, in a server, and you don't need to waste one of the GPUs. If you have a K1, essentially you do it 4 times. So I don't think I want to spend too much time on this here, but essentially, there's clearly a difference between virtual desktop and virtual applications. One case you have the full desktop, and in the other case you just get the applications. I think the most exciting part will be actually to show you the different videos and to show you what the difference in performance is. Similar here, again a little animation. You get the full desktop using virtual desktop. Or you using XenApp, and a server delivers you these different applications, whether it's an Internet Explorer, an Outlook, or maybe Word, or one server can even serve 2 different kind of applications. So let's get to the more exciting portion of it, the user examples. So as I mentioned before, you need to think about the different users. I think you can classify them in 3 different kind of categories, or 3 different types: designers, power users, and knowledge workers. We view this in 2 different classes. One essentially is the virtual remote workstation where the designer sits. These need really kind of graphics, very graphic intense applications like CATIA, Inventor, SolidWorks, and these type of AutoCAD applications. So they need actually dedicated GPU because that's what they had actually in their workstation too. Then you have the second class of users, which are virtual desktop. They use virtualized GPUs. They can share resources. On the upper end, you have your power users. These are your PLM or medical imaging kind of type of applications, Showcase, Photoshop, and then at the knowledge worker level, you have maybe Office, HTML5, and Google Earth, or and I will show you quite a few in the next couple of minutes. So what I want to do now, essentially, I want to take these 3 different kind of user types and make a quick matrix here. Essentially, how does the experience look like with no GPU, with a shared GPU, and with pass-through? For each different kind of user types, I will pick different applications, and I will show you side-by-side videos, and you can judge for yourself whether it's worth it to have a GPU. In the first case, essentially, we'll show you SolidWorks and Siemens NX. In the second case, for the power user, I will show you Photoshop. I think all of us essentially have a little bit of a power user now, whether, because we all have vacation photos, we maybe want to spruce up a little bit and edit a little bit. And finally, at the knowledge worker level, I will show you some examples of HTML5, Google Earth, PowerPoint, and then Windows Aero. So let's get started. So the first one is Designer, SolidWorks, and Siemens. So what you see here is Dassault Solidworks of a model of 2 screen captured of 2 live VDI sessions. On the left-hand side, you have the no GPU version. Clearly, the good news is it runs. That's exactly what I was mentioning, that SolidWorks is smart. It realizes that you don't have a GPU, and therefore kind of realizes that you can render on a CPU and downgrades the experience a little bit. So clearly, it runs. You can do the different slices, but you also see a clear difference between the GPU and the non-GPU version. It's not as seamless, you know, it rotates not as quickly, and you have also a very different level of detail there. So if you are a designer and you give them the left experience, they would say, you know, I can't do this for 8 hours. This is not the experience I'm expecting, or, you know, if I have a workstation on my desk, I can't do this. But on the same side, on this, you know, if you would give them the right experience with GPU pass-through, it's very seamless. It has essentially workstation quality. So in fact, I was talking to a designer, and he was playing with this model, and he couldn't tell really the difference between the VDI session and his workstation. So it's very seamless. It's a great experience. So let's take a look at the second case. Here I have a Siemens NX using XenApp, GPU accelerated. So you can see that, you know, it's very seamless. Essentially, you know, I'm not, you know, I kind of recorded this myself here. I'm not an expert user of Siemens NX, but I tried my best, and it felt, you know, very responsive. You can do all these different things. Now I think I'm measuring something from one side to the other. You can rotate it. In fact, you know, this server actually is located in California, and just before this talk, we actually tried out Connect to the server right from our booth, and yeah, the experience was actually still quite good, despite the fact that we are now about 6,000 miles away, and it was quite impressive. So you get a great experience essentially if you use GPU acceleration with XenApp. So let's tally up. This was a K2. Yes. I haven't particular kind of tried out comparison between K1 and K2. I think this model is actually maybe not the most, you're talking about the XenApp one, right? This was definitely not the most demanding model. I think the experience would be very similar to between K1 and K2, but I personally haven't tried it out myself. So let's tally up. So I think hopefully we agree that in terms of, you know, for at least for designer level, the no GPU version, you know, I think designer would not be happy with this. You know, would have a very hard time convince him to work on this experience for 8 hours. The shared GPU is actually, in fact, very similar to the no GPU, because these applications, when they load up, they will try to find whether they find NVIDIA hardware, or they find a driver. If they don't find the driver, they simply decide, okay, well, I'm going to render on the CPU, independent what the whole stack is. And therefore, essentially, no GPU and shared GPU is the experience pretty much the same, because that's what the software simply does. Therefore, essentially, we would also say this is a no pass here. Pass-through, I hope I was able to convince you that SolidWorks actually ran very smoothly. And unfortunately, we don't have a live demo here where you can actually play with this well yourself, but it's quite amazing. It feels just like it's there. So let's go to the next category, the power user, and take a look at an example of Photoshop. So again, this is a recording of 2 VDI sessions. On the left-hand side, the no GPU version is CPU emulated graphics. On the right-hand side, you have running it on grid. Clearly, it runs, but essentially experience is quite different. So I think we saw earlier that whenever you use OpenGL calls, the no GPU version will actually give you an error message and will tell you that it can do certain things, especially if you use effects, which you'll use OpenCL. Then basically you will simply not do these effects. And clearly, if you see the difference in responsiveness, I mean, this is an error message, for example. There's a clearly difference between the no GPU version and the GPU version. I mean, just alone the responsiveness of the application itself. So here, since we're comparing these 3 different kind of modes, I'm comparing now shared GPU with GPU pass-through. The responsiveness of the shared GPU is definitely significantly better. But because Photoshop relies on a certain level of OpenGL, and in shared GPU we have only OpenGL 2.1, and so whenever you require API calls above that, you will get error messages. But I think, if you're not the most demanding, or your particular kind of effects you're using in Photoshop don't require this, I think it's a fair way of using it, and I think you get actually quite good results. But I think the GPU pass-through mode definitely adds you a little bit more, which is expected, right? So again, so let's tally up. I think in terms of the no GPU version, I think it was not quite there. I'm not sure. Maybe if you have a few vacation photos and you want to do this, and you don't use these particular effects, you might say, okay, well, it's okay, I can live with this. But I think if you're more serious and you're actually using Photoshop, you will be quite quickly annoyed, and you say, this is not for me. On the shared GPU, I think it's a toss-up, essentially, depending on the experience. Actually, it's not too bad. And if you're not using calls which are beyond OpenGL 2.1, I think you will be fine. So it's kind of a little bit application dependent, but shared GPU definitely kind of improves the user experience. Pass-through, again, it's a very good experience, and it's very seamless, and it's great. So let's go to the last one, because that's actually maybe the biggest amount of people who actually you want to convince of VDI. I mean, these are the majority of people who have today a certain kind of, whether it's a laptop or another workstation, and you want to give them experience which they're used to today. And so what would that be? So I mean, HTML5 is about to become mainstream. It will become more and more. And I will show you some examples on, yes, I picked some demanding HTML5 applications, or an example. But I think in the future we will see more and more of that. So just to kind of give you a feel, essentially, how these GPU handle this. Then I will show you also a Google Earth example. I will show you PowerPoint with transitions and how that does. And finally, Windows Aero to see how Windows Aero is handled in these three different kind of modes. The first one is WebGL and HTML5. This is running Chrome here. In the no GPU version, the browser simply doesn't load it. It says, this is what you get. It's like, page not load, of course, that's something I added, but essentially it loads up, it's a black screen. On the other side, essentially, I have to admit this is quite demanding, but I think if you go and open your laptop right now and you would go to this URL and play around it, I mean, you have actually quite great experience on your notebook. And so you would expect, essentially, if you give to your users a VDI session and they have this expectation on their laptop, they're probably, if they want to have a VDI session, they probably want to see the same experience. And it does actually very well. You can rotate seamlessly. You have a lot of particles flying around, and it feels great. I was quite surprised. But I have to say, this is a very demanding application. This one is actually run on a K2, and it probably looks harder than it actually is. So let's go to the next one. Yes. So here you have comparison of shared GPU versus GPU pass-through. What I should add here, these were kind of full screen models. I had a 1920 by 1080 display where screen captured, and you can see that the shared GPU, has a hard time here. But I need to admit that basically if you decrease the size of the window, it gets significantly better. And basically it plays very well. Rotation is still kind of a little difficult, but it does much better performance than what I'm showing here in the full resolution or in full screen mode. Pass through again in comparison, it's very fluent, and experience actually is great. So let's take a look at Google Earth. And this is again run on a K2. This is a fly into, let's take a look, we're flying into Paris. Yeah, I think it's a very seamless kind of experience, and it's very similar to what you would get if you open your laptop and you do the same thing there. Essentially, if you have a good internet connection, you stream all the details in, you get a very similar experience to this VDI session. If you do it without GPU, essentially, I have a quick screenshot in the next slide, but essentially it's not even doing anything. Essentially, Google Earth loads up, yes. It complains in the beginning about that, you need to revert to OpenGL, and even then it's not a really great experience. I haven't run Google Earth on shared GPU, so I personally just asked a colleague, and he said it wasn't that great, but I personally haven't seen it, so but I think it's not as good as in the pass-through mode. And finally, maybe the number one application is Windows itself, Windows Aero. If you don't have a GPU, then simply it doesn't work. And here are these two images. One inside is you have Google Earth, essentially without GPU. That's what you get. You get this outline of an Earth with some kind of yellow lines here outlining the continents, and you zoom in and you see just some icons flopping around, but I think you cannot make out you can't make out the map. As I pointed out, Chrome or this particular site didn't even launch. And also Windows Aero doesn't launch, and you don't get the experience, you cannot use it. Whether you want this or not, that's a different question. But on the other side, if we have GPU pass-through, it works seamlessly. All the different kind of Aero features are there. And finally, I compared here shared GPU of a PowerPoint presentation, and I looked essentially at different kind of transitions, comparing GPU pass-through to a shared GPU, and I think shared GPU does a very good job. If I would cover essentially shared GPU and GPU pass-through, I personally couldn't tell the difference. Maybe if you very look hard and you really want to sell GPUs, you may see some benefit on the GPU side, but yeah, I don't see the difference. So I think that's definitely a pass for shared GPU, and even the no GPU version essentially for these type of things is the difference is little. Just looking at PowerPoint transitions, for example, people probably could live with that. So again, let's tally up essentially. So we have seen different applications. So clearly, whether no GPU is okay for a knowledge worker depends heavily on which application you use. If you rely on Google Earth, if you rely on particular HTML5 aspects, you will be not happy not having a GPU, right? But if you're only doing certain kind of, PowerPoint, for example, in a limited, not too fancy way, you're probably fine. So I give this kind of, probably, you can, depending on your use cases, you could live without a GPU. In shared GPU mode, essentially, again, depending on the applications, which OpenGL calls you need to make, most likely you're going to be fine. But the experience is definitely kind of a little less than in pass-through, but again, applications matter. And finally, pass-through again, I mean, you get a great experience there. It is a true desktop experience. So let's sum up here quickly. So in terms of here, I listed all the different kind of grid-enabled solutions which are released today. So in terms of virtualized applications, there's Citrix XenApp 6.5 with OpenGL 4.3. It uses our NVIDIA driver. It works on both Grid K1 and K2, and you get a full benefit there. And that's the reason why it has full NVIDIA Grid CUDA support. It supports Grid DirectX 9, 10, and 11, and OpenGL 4.3. On the virtual desktop side, there are multiple solutions out there. You have Citrix CentOS Sub 5.6 Feature Pack 1. with NVIDIA Grid software. Here you have again the NVIDIA Grid driver. It supports both Grid K1, K2 cards, and you get the full package: CUDA, DirectX 9, 10, and 11, and OpenGL 4.3. Then you have two shared GPU models. One is with Microsoft RemoteFX using Windows Server 2012, and you have VMware View 5.2 with VSGA. Here you do not directly use the NVIDIA driver, and for that reason you use an API intercept model, and therefore you downgrade it to DirectX 9, 10, and 11, and OpenGL 1.1 in a Microsoft case. That's fine actually in some cases if your applications don't, or I think 1.2 depending on, I think Benny you talked about 1.2. If that's fine with you, then this is actually a great mode, but if you require more, then you need to think about other alternatives. But Grid K1, K2 supports this mode. Maybe one step up is VMware with View 5.2 and VSGA. It utilizes DirectX 9 and OpenGL 2.1, and again both of the cards are supported. And finally, the virtual remote workstation. Here you would use Xen Desktop 5.6 with Featureback 1. Again, use the driver. You have actually remote workstation certification from us. You get a full-fledged kind of API, CUDA, DirectX 9, 10, and 11, OpenGL 4.3, and depending on which card you have, you can either have 4 users because you have 4 GPUs, or you have 2 users with Grid K2 to get remote workstation. So let's recap. So I kind of briefly talked about who NVIDIA, what kind of products we offer, from smartphones all the way to superphones and everything in between. Then I showed you essentially why we believe that, or what Grid brings to VDI, why we believe that you have to have GPU acceleration for VDI solution. Then I talked about the different Grid-enabled solutions, whether it's pass-through, software virtualization, or true hardware virtualization of the GPU. And finally, I showed you different kind of user profiles and experiences, and what actually in real life you would expect once you put a GPU into your servers. And so hopefully I was able to convince you of the 2 things I tried to promise you in the beginning, that I was able to show you the clear benefits of GPU acceleration for VDI, and that today you can deliver a true PC experience for everyone anywhere. Thank you. Any questions?
If I was to fill my servers full of grid cards,
yes,
and keep the same thin clients, would I still be dependent on scraping the frame buffer or offloading GDI primitives and encoded media, or does it change the way that the graphics get to the thin client?
Oh, I think that's very technical.
Sorry, I couldn't hear, so say it again.
If I fill my servers full of grid cards,
Yes.
but I keep the same thin clients,
Yes.
am I still dependent on scraping the frame buffer and offloading GDI primitives and encoded media, or does it change the way that the graphics get to the thin client?
I think that depends to some extent on the software stack. You're presumably wanting to render video on the server and then just send that out to the client. So are you thinking of having thin clients without any real rendering capability?
Yeah, I'm wondering if this is purely a server-side technology and you still have the same problems that the thin clients have, or whether it's an end-to-end solution.
This is very much a server side for the moment. Yeah, let's not go further than that. I mean, we have Tegra was mentioned. Tegra is our system on a chip. Tegra one day might make a really interesting thin client, but I'm not promising anything there. But so for the moment, it's server.
But I think just to add there, you definitely need to have, in order to enjoy all this rich graphics, you need to have enough compute power on your client. If the client gets too thin, you will encounter problems.
question regarding the support of good software that it will be hypervised Zen server, correct?
Yes.
Is there any plans for VMware
For the complete virtualization?
Correct. Hardware virtualization.
Well, I think well, I think we want that. We want that very much, and I'm actually quite confident that VMware will probably implement this at some point, but I don't have right now a date when this might be happening. Yes. Same answer. So I mean, we are actually we have no preference in terms of which virtualization partner is out there.
If you have a preference, sounds like you're a VMware user, tell VMware that you want this technology.
Yes.
It's on the table for them to take, really.
So we're not
NVIDIA has
limiting
it on the, so the more you tell them, and feel free to tell Microsoft as well, but you know, you might be on a hiding to nothing there. But tell VMware, for sure. Anytime you see a VMware rep, we want the NVIDIA technology.
AutoCAD is a bit of a challenge.
Yeah, I mean, so one of the challenges is there is VSGA out there, and VSGA is great for certain applications, but it has limitations, and one essentially is that pretty much the application will actually look for the driver, it cannot find it, it will deliver a different experience, and it is what it is. And yeah, so there yeah. Yes.
Of the 3 forthcoming HP ProLine chassis that are going to have the cards integrated with them, are they all blades, or are you planning any wrap mounts?
So there are 3 of them. Essentially, there's the WS460, and then there's SL250 and SL270, these are not blades, right?
Okay.
Yeah.
So the decoding is still on the endpoint?
Once again?
The decoding is still on the endpoint? So like, or is it decoded on the server and then transmitted over the wire to the endpoint?
I still didn't.
The data stream works exactly the same way that it works today on non-GPU accelerated. So if you're using ICA, for example, ICA does get some benefit in the server if you have a GPU, because the compression of the ICA protocol is done on the GPU. So for Citrix, there's a deep compression codec that uses the GPU to do the coding. The decoding on the client side is still just client.
That's actually one of the reasons why your client cannot be too thin. It needs to have some kind of compute power to do exactly that decoding.
Okay. So what kind of bandwidth considerations of non-GPU versus pass-through GPU?
Bare metal considerations, you said?
Bandwidth.
Oh, bandwidth.
Yes.
Sorry.
Well, it's highly dependent on your application. So, but I've seen, just the fact that we can stream from here from our booth, California. I think it's an indication. I don't want to be. I mean, it's very dependent on the application, but I've seen quite good results with something on the order of 10 megabits.
But GPU isn't really making a difference to the bandwidth.
Yeah.
You're still sending a bunch of pixels which represents the screen.
Yeah.
Whether the GPU's there or not, it's still the same bunch of pixels. Yeah. It's still the same picture.
Yeah.
So we don't make any difference to the bandwidth per se.
Yeah.
So SLs are tray servers. Are there any plans to put it in DL ProLines?
Okay, so the answer is hopefully.
The answer is a definite maybe.
And one of the challenges is that currently the SL270 and 250, they support passive cards. K1 and K2 are passive cards. In order to have a DL solution, you have to have an active card. And we're working right now on trying to create an active card, but the DL is I think the DL380, for example, has particular physical form factor limitations in terms of how long the card can be and whether you can fit actually an active card in there. And right now we're working on trying to create an active card, but potentially there might be a way to even fit a passive card in it. But I think we're working right now with HP to maybe support that.
The L580s would be more interesting. Would that help the size?
We know I'm sorry, Milan.
Yeah.
We know there's a lot of interest in 380 and 580. We've in the UK at least, as we've gone around and talked to customers, we know there's a lot of installed base of 380 and 580. So that's been fed back to this gentleman who sits in California and can help us with that.
And
So it is.
as well.
Sorry.
Plus one on the high devices as well.
Yeah. So
And I think one favor you can do me is, if you have that platform, to communicate very well back to HP that you would like to have that. So that would help us also to kind of create the business cases that, there's a ton of people who want this, right? And also accelerate essentially the qualification of these type of cards, because it takes quite a bit of effort to take a card, put it in an OEM system, get it qualified, that you can actually purchase it. Yes.
If I have 2 CAD workstations, why would I put a K2 card in a hypervisor as opposed to putting 2 Teradici cards in those 2 workstations? What's the advantage of a K2 card?
Well,
you want me to
one would be, for example, space, right? I mean, 2 workstations are take up significant more space. Cost might be another one. I don't know, how the cost of 2 workstations will compare. In workstations are not data center kind of type of. It's not a server. If you want to have something in a data center, yes. But I think some of these servers essentially, if you turn them on, they're rackable, right? So it becomes a little bit of a question. But I think if you only go even for the cost of cards, I think a K2 is actually cheaper than 2K 5000, for example. So even a cost perspective there, but yeah.
And you probably can get some consolidation. So if you put 2, let's take an example of a Dell R720, you can put 2 K2 boards in there. So with pass-through, you can run 4 VMs. So you're now running 4 users on a single machine, whereas before you had to have 1 workstation per user.
Oh, one more question?
In terms of GPU parser for a design user, is there any benefit in having a high-end CUDA graphics card on a client machine?
Well, that I think depends very much on the application. I think there are, for some certain.
If design application is being manipulated through the parser, any difference between 5,000 or 4,000
in terms of virtualized graphics using a shared GPU, I would have said it's not necessary. That's the whole point, really. You're moving that rendering to the server, and therefore you do need some graphics performance on the client end, as Milan said. You shouldn't get away with the thinnest client you can find, but you don't need a K5000 anymore. You've moved that K5000 into the server, and by the way, you've probably consolidated 4 of those GPUs with 2 K2s.
So there's no, it doesn't offload decompression on the client machine to the GPU or anything like that?
You're still doing decompression in the normal way on the client.
Yeah.
As I say, one day there might be a client based on Tegra, but that's just me as an engineer sort of hoping.
Yes. Okay. Any further questions? If not,
Looks like there's another session maybe about to start.
Okay. Thank you so much.
Thanks.